Hey everybody, and welcome to Let's Look at Algo. Now, before you leave thinking this is another, oh no, DAE, programming video game, it's not like that. It sort of is. But don't go anywhere, okay? It's $10. It just came out on Steam. I purchased this with my own money, in the interest of full disclosure. So I owe this company anything. I bought it on Steam on a Friday night, because I'm kind of interested in these, I'm going to call them Zachtronics lights, you know, like the kinds of games that abstract programming concepts out to like a puzzle game mechanic. So this is a game where you script instructions for a robot to do, and then the robot kind of like, you know, what was it, Lego, what's the Lego robot called? Mindstorms? They kind of like Lego Mindstorms a task for you and completes something, normally involving picking something up, dropping it somewhere, hitting a switch, and then exiting, with the kind of like time and space constraints, and particularly constraints in the amount of instructions that you can have. But it's a puzzle game, okay? It's a lot like Human Resource Machine, except even a little bit more gamified than that. I think it's decent. I'm not gonna bury the lead. I think this is like a 6.5 out of 10. That for like 80% of the population is going to be like a 5, and then for 20% of the population is going to be like a 9. And I just so happen to be in that 20% of the population camp. I spent about 3 hours playing this, had a good time, got a couple of little quirks that I do take a couple of points off for, and we'll see as we get going here. But yeah, I've in 3 hours or so, I've almost beaten the game. Like, I'm almost on the final section here. I just need 1, 2, 3, 4, 5, 6, 7, 8. 8 more puzzles and then the final section. So maybe it's more fair to say that I'm actually just past the halfway point, but still. Let's go back to the early game here, and I don't know, we'll do, I'm actually going to turn down the sound a little bit, because the high-pitched whirring, not to be rude, but it's a little irritating to me. Let's go back to like one of these earlier levels. Like let's go to a load of rubbish. That'll be a good opportunity for me to explain to you how the game works and how it actually expands when we get into deeper puzzles as well. So it does have a story. The central premise of the game is that, you know, you have this robot here that's Gemini. It's kind of like the Eve to your or Eva to your Wall-E. She guides you, and you're kind of a silent protagonist, although it seems weird to say that about a puzzle game. But basically, she gives you kind of exposition, and the space station is collapsing, you gotta save it, but all sorts of wacky hijinks ensue. The story doesn't matter. Not to insult the writers, but the main hook of the game is the scripting sort of gameplay. Don't be alarmed if the jargon is too much, you'll catch on. Technically true. Oh, and it's about time you started using functions to optimize your commands. Okay, so clear this, get this out of here. You can clear this pretty easily. I actually almost, you know what? You're not gonna love this, but I'm gonna go back to the main menu. I'm gonna do a slightly earlier puzzle because I think it explains the progression of the game a little better. So we're gonna go back here and go to like turned around. Every now and then I accidentally get a secondary loading screen. Okay, so you don't need to know this. I'll tell you everything you need to know. Just clear this out of here. I wish there was kind of like a clear option. Maybe if you just right-click on this, if there is. So this is the interface of AlgoBot. This is AlgoBot. Every single one of these circles is a node that you can go to. It represents one step. And these are your instructions that you can use here. So there's go forward, turn 90 degrees to the left, turn 90 degrees to the right, turn 180 degrees in one step, and then this is just AlgoBot's primary ability, which in most cases, in fact in all cases I think, is just push button. So, you know, if you want a quick little example of how this will work, basically each one of these spaces here represents a time step. So what we have to do to complete the level, we have to go forward, push this button, and then go forward to the end. So what we're going to do to start here, I mean, you can probably figure it out for yourself, but you know, you can go forward, and that'll put us here. We'll turn 90 degrees to the left, go forward, push the button. Then we'll do a 180 degree turn. We'll walk forward twice. We'll push the button. We'll do a 180 degree turn. And then if you're like, oh, I can't follow that in my head, Bobby Fischer, I can't see that many moves ahead. Why don't you slow it down? Well, we can do so here using what essentially is the debugger. So this moves us one instruction forward. We go forward. We go forward. The buttons activate because we're one tile away. We turn left. We go forward. Hit the button. There's some quirks with hitting the button. Like, for example, you don't actually have to be facing it, which can actually be important on some of these levels. And then we're going to turn 180 degrees. We'll talk about those later, probably. We'll hit the button, turn 180 degrees, and then you know this is where we are. So what do we have to do next? Forward, turn right, forward. Now, admittedly, one of the things I wish you could do is, while you were essentially watching your puzzle solution, just be like, okay, go forward, See, I just like to go for... If you're doing it step by step, you actually can't add instructions as it's going. I don't even want to add them to finish it. I just want to add them so I don't have to keep the position in my head right now. But we can still do it. It's forward, right, forward, forward. And you're going to say, man, this is super easy. All you got to do is look at what you got to do and then do it. That's where the game gets harder later. And this game, it has wildly, in my experience at least, it has wildly divergent puzzles. Some of them I basically sight read. I saw them for the first time and went, oh, that's simple. I see what you're doing here. We'll just make a quickly reusable function, and then we'll do it over and over. And look at that. We did it with, like, the optimal solution according to the game's... it has, like, a target score that you can hit. So we hit the target score on the first try. And then some of them I spent, like, 20 or 30 minutes on even, which is a little embarrassing. And I'll skip those for this video. But anyway, where it becomes really difficult is obviously... If you wanted to just follow the robot's progress, you could easily... You could imagine like a 1024 turn puzzle. You could just do step by step. But there's always a limited amount of instructions, so you have to do it in the most compact way you conceivably can. Otherwise, like if we did things slightly suboptimally here, like maybe we're like, okay, throw in a U-turn and then another U-turn, we wouldn't actually be able to do anything after that because we'd reach the peak for instructions. One of the things I wish the game would let you do is just be like, hey, this is where you have to solve it in this number of instructions or less to complete the puzzle, but we'll let you put more in so you can kind of like see how your final solution looks and then try to pare it down. But anyway, it does not do that, which is a little bit of a frustration. We're just going to go up to speed 3 here, and there you go. That puzzle's complete. And then we'll just go straight into our next puzzle. And I apologize for skipping the dialogue, but I just don't care about the actual... The story, more or less. That's just who I am as a person and as a player. So we used 14 commands. Target score is 14. Best score is 14. It would have been hard to do worse than that, but I think it's impossible to do better than that. It's just, there's kind of like one line that seems obvious, which is not true for every puzzle. So this is the one we looked at earlier, and this is really where the game starts to blossom, is when they give you functions. Now, I'm not going to belabor the point and make it about programming, but essentially functions are reusable bits of instructions that, like, there's a, let's learn by example. Like, if we look at this here, the whole level is very simple, right? It's forward, forward, right, forward, button press, left, so that we're facing the way that we want to go again. Forward, forward, right, forward, button press, left. So you can see we're repeating the same instruction over and over. So rather than go like forward, forward, right, forward, press, and then just repeat this, and you can see like where we go when we do this, like so. Rather than just repeat this over and over and over, which would lead to us maybe even running out of space, what we can do is just instead move all this down here. So forward, forward, right, forward, button press, turn left, and then delete all these, and then we can use our function instead. And there might be a more optimal way to do this, but I think we just put one of these at the end and that should do it. So we can watch it get played here. Instead of using, like, we're literally using 6 instructions to hit the first button. So if we did it up here, it would have taken us 19 instructions. 3 times F1 plus the 1 extra forward arrow that we have at the end. Instead, we're using 4 instructions because we put some of our reusable instructions inside of a function. So for many people, you're probably going, hey, Dad, I know what a function is. And I'm going, you know what? Okay. But it's really neat how they introduce them in this puzzle game to make things a little bit more interesting. So that gives you, I think, a little bit of like what you need to know in order to understand the fundamentals of Algobot. Let's go into some puzzles that are like a little bit more difficult. So let's go into, and I don't, like, strictly speaking, I don't remember how to do any of these, so let's try this one right here. I don't remember like the names of the puzzles and what they entail, so there is a chance that I could get stuck on one of these again, even though I've done them before. Come down, Algobot. That was a rhetorical question. Are we there yet? Okay, Algobot is not a silent protagonist. Again, I don't necessarily think the story is one of the strong suits. So one of the things they introduce a little bit closer to the mid-game here is the second function. And now, again, I don't want to go full DAE mode, but what you could do is, like, nest this function inside of this function. So you should go, like, or you could go, function 1 calls, like, forward, download, which I'll talk about, left, forward, right, forward, download, left, or something like that. And then you could be like, okay, and then it has function 2 inside of it somewhere, and function 2 contains like a little bit of code itself. So you could actually call like 12 or even more than 12. What is 1, 2, 3, 4, 5, 6, 7, 8? These are 8. You could call 16 instructions with a single call. If you did like, forward, forward. Let's just say function 2 is like this. In fact, you could call more than 16 instructions simultaneously. Because you'd be like, okay, F2 is just move ahead 8 spaces. And then F1 is do that 8 times. So you could move 64 spaces, in theory, with a single call here, whereas it would take you 64 of them to do it with exclusively up arrows, or if you wanted to do it exclusively with, function 2, it would take you 8 of these. So it would take you like half your space on the machine here. It's just an example. It's not actually good, obviously, but it's an example of how the power of functions is it allows you to call a lot of instructions without actually forcing you to, be beholden to the space constraint as much as you otherwise would. So let's look at this puzzle. The down arrows, which are up arrows because of our camera perspective, and I actually do think that's one of the weaknesses of the game, is that sometimes I found the camera perspective distracting, and I don't find the art style particularly, inspired either, but I really feel like, in Zachtronics games or, Silicon Zeros or, I'm trying to think of what the Human Resource Machine, it had kind of a fixed perspective that allowed you to focus on the mechanics of the puzzle, whereas in this, sometimes the camera's, to your right side, sometimes it's behind you, 3/4, etc. And I just find that it adds, sure, there's some visual variety, but it's not really, that doesn't really excite me. It's more like it causes a distraction. And even worse, sometimes, especially when you're first starting to play, you're like, oh, can I interact with the turbines, or are those just kind of like an environmental accent? Can I interact with the stasis chamber, or is that just flavor, Yeah, eventually you figure it out, but I do think it muddles the design a little bit and is needlessly beholden to this kind of sci-fi aesthetic that doesn't necessarily add a whole lot to the game, all things considered. But anyway, I'm getting up my own butt, so to speak. So these arrows essentially mean that we download. So we can download from A, and again, because of the thing here, you can't really see that says A right here, but we want to download data from A, and we'll store it in red, which is just like that, basically. So this stores a value. And then at some point, we're going to want to download data from B and store it in green. So we can hold 2 different values, one from A and one from B. And then we want to eventually get over here, and we're going to broadcast our red to A, because that's the color that we use to download, and then we're going to broadcast, and I keep making this mistake as well, but we're going to broadcast B, or green, to B over here. So that's essentially what we're going to do here. So let's look at how this would work. We do have a repeating element for sure, and it's forward, left, forward, right, forward, forward, with 2 downloads in the middle. Where do we do that again? Right here. Forward? Well, it's really like forward something, which is bad because where are we going to insert that in the puzzle? Anyway, let's figure it out on the fly. So we can make one function, which would just be, let's just put all of our downloads into function 1 and then all of our uploads into function 2. And that might actually be the optimal solution. So it'd be like forward, download, and it'll automatically be red to start with. Left, forward, right, forward, forward, and then we'll download green. Whoops, again, every time. I really feel like you should just be able to, this should be like a toggle, which one you want, and then when you click on this, it should automatically do that instead of having to essentially paint it, but so be it. So this, if we play it forward, should take us, oh, we haven't put it on the instruction stack yet. This should put us right here, facing this direction, facing forward, and having downloaded 2 pieces of data here that are stored in red and green respectively. And then we get an error because we haven't put any more instructions. So what we could do after that is just be like, okay, we'll put, left, forward, right, forward, forward, right, forward, forward. And what we do when we have this is kind of like a hacky way to do it, but it's a good way to see elements that you can consolidate. Right now I can already see left, forward, right, forward, forward is a pattern that we use all the time. Left, forward, right, forward, forward, right? So we can actually consolidate one of our functions to just hold this, but should put us right here. So if we wanted to, and it would be suboptimal, we have enough space though. What we could do here is just finish it off, which is a left, forward, upload red, left, forward, right, forward, forward. Upload green. Left, forward, right, forward, forward. So I think we might have actually, and if I sound like I'm a professor like lecturing you right now, I apologize. But I think I've explained it pretty well. You know, we've made this, and I think this solution should work, but this might actually be the worst solution that actually still passes the test. So let's put this on speed 3 and see if my mental algorithm was correct here. So it picks up both variables, and then it comes back, and now we're into the hard-coded stuff. It uploads A, it uploads B, and then it leaves. But that sucked. That was bad. And we'll see when we're done with this here that, you know, this is not going to be our optimal solution. Like, yeah, we use 32 commands. The target is 18, and previously we've done 20. So let's retry this and make it better. This is really the process you go through to solve puzzles, and this is where you're either going to like it or you're going to hate it. Because this is where it scratches kind of like that refactoring programming itch that I don't think you need to be a programmer to like, but if you like programming, you know that you probably already like it. So really what you do is you identify patterns that get used over and over, left, up, right, forward, forward, and then you just consolidate those into a single function. So let's make function 2 our reused piece of code. Or instruction. Left, up, right, forward, forward. We use that so many times. We used it 3 times. We also use it right here. So right off the bat, we can make this better and put that there. And it'll still work, and this will take us to here, and it'll download. And then we want to call it again. And I think let's just play it forward here. And we should see, like, look at how much we can get done with one instruction here. I can't click on the button because Sinvicta just signed on to play The Binding of Isaac Rebirth. So hopefully this actually works. But look at this, with one instruction, okay, we've still downloaded everything. And we made it there. Now, unfortunately here, we're going to have to use a little bit of hard coding, right? Because we got to turn right, forward, forward. There might be a better way to do this, but anyway, we got to go right, forward, forward without doing the left plus. I'm thinking like, okay, what if we did, and this might actually work and be hilarious. I want to try it. So if we go left, we're going to be facing the wrong direction, and then we're going to go forward in the wrong direction. Nah, I don't think we should do it. Because what we can, some solutions are basically like, you know, you want to keep your function as tight as possible and reusable as possible, so you might deliberately face the wrong direction, even though it takes one extra step, and then your function will turn you around and put you in the spot. So I was like, okay, what if we faced in a U-turn, and then walked? It would not work, I think. Okay, so we're facing this direction, so then it would be right, forward, forward. This is what I mean, where like maybe even right, forward, forward could be distilled into its own function instead of like this one right here just being essentially some kind of like magic numbers hard coding. But anyway, then it's going to be left, forward, upload, red, and then left, forward, right, forward, forward. So we'd do function 2, upload green, and then it's left, forward, right, forward. Left, forward, right, forward. So again, you know, maybe we take this out of here and it makes it easier for us, but I'm not sure. Anyway, I think this should work, and this kind of demonstrates how, like in a Zachtronics game, you can, you know, get a solution that works, even though it is a little tricky sometimes, and then eventually you look at it and you see ways that it can be improved, and I mean, look at that. Oh, we're missing one more, which actually means that I'm stupid, and we can make this way better by just doing that. So put it on speed 3, and go ahead. I believe that you are going to get this done. Beautiful. So that might not be 18, but it was definitely way less than 32, and that's actually like a better proof of concept than I ever could have hoped for. Yeah, we used 20 again, so there is a better way to do that. So, I mean, I do like the game. I want to make that clear, and this is not the end of the video, and as you can tell by the viewing length, I'm sure, but it's not that I don't like the game, because I find this loop really satisfying. And it's not just because, you know, I've been learning how to code for a long time now. It's that It's just like an innately satisfying loop to kind of struggle and use your brain to come up with a solution. And then sometimes your solution is going to be too long, so you're like, okay, that's obviously not the way to do it. What if I think outside the box? Like, what if instead of going around it in a clockwise fashion, I go around counterclockwise? Like, maybe that'll be 10 steps faster or something like that. But it does suffer in comparison to games like particularly Shenzhen.io and Opus Magnum. For one, the options for the game are essentially bereft. There's really just play the story mode and that's it. And I think the interface is a little bit wonkier than in the Zachtronics games, and there are other games like this, like Human Resource Machine as well. But I think it sort of lacks a little bit of the charm of Human Resource Machine, and then it also doesn't really hit the same kind of like robustness as a Zachtronics game, especially in terms of like length, replayability, and etc., etc. I don't think it looks particularly great. I don't think it sounds particularly great, but I still like the core gameplay loop. But I say this just as a way of being like, you know, it's not for everybody. But before we finish this up here, maybe we can do like a different puzzle. We'll do like one of these ones on the 3rd floor. They haven't really introduced any more mechanics at this point. They've just gotten a little bit more complex. Although this one, I think, actually is kind of on the easier side. Although if you look at it, my solution essentially used up all the space. So I must have had a hard time doing this one to begin with. So let's see if we can make it better. I mean, I can already see, I played this game at like 2 a.m. last night. So I can already see something we can do to make it better. Like, for example, why would you have upright up in here when you could just call function 1 right there instead? But anyway, let's get this whole thing taken care of. So we have some renewable elements. Like we have some patterns. Like this is like Big Dipper here of straight, left, straight, right, straight, 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 right, straight. Like that is going to be used over and over. So let's put that in here somewhere. So that's going to be like 1, 2, 3, 4, 5, 6, 7 tiles long. I don't think we're going to be able to get there the whole way, but let's start it. So it'll be like straight, left, straight, right. And then we could just call like another function here. We could call it like in this one, this allows us to go around a corner. So it's kind of like reusable in that way, right? Like it allows us to go around a Z pattern, I should say. So maybe we want that. And then we can also have something that allows us to go around like this triangle here. So this puts us, let's see, forward, left, forward, right. We're facing this way. We want like forward, 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 right, forward. Forward, 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 right, forward. So how would we do this? Well, we would start with like an upright up, which again, I don't like to hard code this stuff because it usually means that there's a better solution. And then we'd have a download for red on this button. Then we could call function 2. Followed by function 1. That should put us here, and we can get a download of green. Let me see, because this is a little bit more of a difficult solution here. Let's see if this is actually, like, functional. Seems to be working. Okay, so what do we do after this point? Well, if we do another, like, U-turn function 2... function 1, that should put us right here. As much as it sounds like I might be doing some kind of witchcraft to know that that would put us there without walking through the steps, it's just because we've deliberately planned around this shape, this like little weird like pseudo Big Dipper shape right here. So this is just the same thing rotated 90 degrees counterclockwise, right? So we should just be able to upload red there, and this should work. I also wish the debugger allowed you to step forward much faster, but that's something for a different day. I wish I didn't have to watch the robot's animation the whole time. Yeah, so there you can see that it's uploading there. And then it's the same thing. If we pull a U-turn, F2, and then F1, we should be able to upload green. Now you see the problem, though, is that we're quite clearly gonna not have enough instructions to get to the exit. So what do we do there? Well, we start to look for things that we can reuse. And there's a very obvious one. Every time we call F2, we're calling F1 right after it, right? So why don't we just put F1 inside of F2 more or less, and then we can clear that, clear that, clear that. We got a little bit more space, and really functionally, Nothing should change there. So we should end at having broadcasted right here. That indeed does appear to have worked. So then it would be like U-turn. And really, after doing the U-turn, forward, right, forward, right, exit would do it. Maybe, I think I'm in like exactly the same situation here that I was in my last one. Because like, okay, we're right here, we do a U-turn. Do we have to do a U-turn or could we just... No, we do have to do a U-turn, I think. So it'd be like forward, right, forward. And we really want to do this twice. So obviously we're going to run out of space. And this is where I wish we had kind of like a buffer that we could play around with just to see how it would look. Let's try to solve this on the fly here. So we're going in, we're going through. And you can see we're 1 3 instruction step away from finishing. So I see 2 things that we could do here. One of them is every time except 1 that we call function 2, we start with a U-turn. So I'm going to put a U-turn to start with here. And then I'm going to purge this U-turn and this U-turn. And then if we put 1 in front of the one that didn't have a call before, this should save us 1 instruction space, but we'll make sure it still works because sometimes this goes terribly wrong. And again, it's kind of a hack way to do it. Yeah, this is clearly not... Oh, this one should go. This is clearly not necessarily the optimal way to do it, but it might still work regardless. Let's see. Yeah, okay. So now we're really only 1 step away. We do need to kill this. Oh, no, we don't, actually. Hold up, because if we... kill this, we might just be able to put this here. I know I'm kind of getting into like I'm the only one that's really following what I'm talking about, not because it's complex, but because I'm not explaining it very well. But I kind of think that we might have just discovered a possible solution here. But let's see if it works, and if it doesn't, that's fine too. Clearly it does not. Okay, so let's purge this. So right now we've got we've made a bunch of extra space for us. Do we have enough space? Well, let's see where we finish. What I'm going to say, though, is do we have enough space to do like a forward, right, forward, right, forward? Forward, right, forward, right. No, we're still 1 space shy. But we have made some space for ourselves, which is good. And we have to do a U-turn here as well, so it's even harder. But, like, I'm thinking U-turn, forward, then it's a left. That's the problem. Okay. So the last thing I'm going to do here is I'm going to purge these, and this is going to take forever. But I'm going to move the forward into F2. And I'm going to take them out of F1. That way we can reuse upright up instead. So instead of calling upright up here, we'll just call F1. And then at the end, we're probably going to have to do a U-turn and fix it. But I think that this might actually be closer to an optimal solution. And basically all I'm doing is looking at my solution and seeing where I'm needlessly... by hand repeating instructions and instead putting them in something that I can call that's actually cheaper and easier. Okay, so this is where we end. All we need is, from this point, is a U-turn, an upright up, and an upright up. So like a U-turn, an upright up, and an upright up. So this should finish the puzzle. And I think this does a great job of demonstrating that the game strikes a pretty good balance between like being able to, you know, through trial and error, hack out a solution that works but is not necessarily optimal. And then if you really look at it, you can go, okay, you know what? There's ways that we can pare this solution down and make it much better. There might even be ways that we can pare this solution down, but like let's see if we matched what the developers were looking for here. Oh wow, we used 23. The target score is 19. So there is probably one other way that we can refactor this and make it more optimal. But anyway, this is AlgoBot. Is it a DAE programming game? Mildly, but not nearly to the same extent as like the average, you know, Zachtronics game. Although Opus Magnum is pretty... I think it's inspired by stuff like that. But anyway, Opus Magnum is pretty user-friendly as well. Is it as good as Opus Magnum? I think no, but it's also 40% the price. or 60% cheaper if you want to phrase things in the way they're commonly used in English. And it's pretty long. Like, again, I've been playing it for 3 hours or so, and I roughly know what I'm doing when it comes to this stuff. If you're a super genius, you'll probably be able to get through it in that time, but I've made it a little past the halfway point. And the puzzles, they range from, like, trivial to sort of beguiling, and you find your own genius in the solutions from time to time, which is really satisfying. So, far from a perfect game, but a game that's very interesting, I think, if you're, you know, these don't come out all that often. So if you're into these kind of games, this is like a mild thumbs up, I think. It's not quite the home run of a Shenzhen IO or an Opus Magnum, or a TIS 100. I know they're all, that's why I call them Zachtronics, like, they're almost all from the same dude. The same company, I should say. But it's good. I've had a good time with it, and it's kept me engaged throughout. Not like, if you look at it as the sum of its whole, graphically, auditorily, maybe I should say, narratively, that stuff doesn't necessarily tickle my fancy, but the gameplay's there. I think it's pretty good. And it's relatively cheap, $10 on Steam. For now, thanks for watching. I hope you've enjoyed the episode. If you did, click the like button. It helps out a great deal. Of course, subscribe if you want to see more in the future. But for now, thanks for watching. And I will see you next time. And of course, there will be a link in the video description below to pick up Algo on Steam if you're interested. If you like what you see, support the developers. For now, thanks for watching. And I'll see you next time.